drawn parallel to one side of a triangle to intersect in the other two sides in distinct points. The other two sides are divided in the same ratio. इस तरह से इसका डायग्राम ड्रॉ करेंगे. A line is parallel to the side of a triangle. Say the name of the triangle is A, B, C. These points D and F, these are two distinct points. If a line is parallel to this side of a triangle, then it must divide the remaining two sides in the same ratio. Okay, so what is the given? Given is DF is parallel to BC. To show that these two distinct points divide these two sides in the same ratio, AD upon DB is equals to AF upon FC. Construction. Join BF and draw perpendicular FE on AB like this. Name it E. Again, join similarly DC and draw perpendicular DH on AC. Proof. Triangle area of triangle ADF, which is half base into height. In this triangle ADF, there is a base AD and height EF. Again, the second triangle BDF, area half base height. What is the base for this triangle? Is BD and height is again EF. Now divide 1 and 2, these two equations. Area of triangle ADF upon area of triangle BDF is equals to this side 1 by 2 AD EF upon 1 by 2 BD and EF. This is AD upon BD. Say this is the third equation. Now see the other side. Again triangle ADF, area of triangle ADF, which is half base height half. This time base become EF and this height become DH. Second triangle, triangle CFD, half base into height half. What is the base for this side? CF. And height is dh. This become 4 and 5. Divide equation 4 and 5. What we have? This area triangle ADF upon area triangle CFD is equals to half AF DH and half CF DH. By cancelling out, what we are left? AF upon CF. This become equation 4. In equation 3, this one and 4, area of triangle BDF is equals to area of triangle CFD. Mean to say, ये दो ट्राइंगल्स हैं और ये, इन दोनों का जो एरिया इक्वल होगा, बिकॉज ट्राइंगल्स ऑन सेम बेस बिटवीन सेम पैरेलल्स लाइन्स are equal in area. So ये जो ट्राइंगल्स हैं, ये दोनों एक बार फिर देखते हैं. ये दोनों ट्राइंगल्स, these two triangles like triangle BDF and CFD are on the same base and between same parallels. In this situation, both areas of these triangles are equal. Now see this one, area of triangle ADF upon area of triangle BDF. On the other side, again area of triangle ADF upon this side CFD, area of triangle CFD, both equal. So this side, this ratio is equals to AD upon BD. We'll write here AD upon BD, and this ratio is equals to AF upon CF. So we'll write AF upon CF in place of AF upon CF. Implies is AD upon DB is equals to AF upon FC. So यही थ्योरम थी जो हमें प्रूव करनी थी. This is the theorem 6.2, which is the converse of this BPT theorem. If a line divide any two sides of a triangle in the same ratio, see this side, the diagram A, B, C. If a line divide any two sides of a triangle in the same ratio like this, draw a line DF, and this line divide these two sides in the same ratio, that is given is AD upon DB is equals to AF upon FC. This time this ratio is given. What we need to prove? To prove or to show that this line, then the line is parallel to the third side. We need to prove that this DF is parallel to BC. Again construction. Draw a line, say DE, or say DE parallel to BC, and we show the line like this. DE is parallel to BC if proof by construction DE is parallel to BC, then because of this theorem, if any line is parallel to the third side of a triangle, then the ratio of other two sides must equal. So it means if DE is parallel to BC, then we need to write AD, the ratio of this AD upon DB is equals to AE upon EC using this theorem. Say 1, but what we have in the given, that AD ratio DB is equals to AF upon FC. So this ratio is given. In both 1 and 2, you can clearly see this side is equal. If the left side is equal of these two equations, then it must that right side of these two equations are equal. Implies this, we can write this side also equal to this one, AF upon FC. Now the ratio of AE upon EC and AF upon FC is equal. This situation can be possible only if E and F, these 2 points, are not 2 different points. This situation happens only when E and F are the same points. If E and F are equal, then we changed this point E with F in our construction. From construction, DE is parallel to BC because E and F are equal. From this relation, we replace or we interchange this E with F. Hence, we can see that the true proof is DF is parallel to BC. If the ratio is equal, then line must parallel to the third side. Hence, this results proof.